Hey, it's Coach Stricker, and I'm going to talk to you guys about redox reactions today. And the first and most important thing to understand about oxidation reduction reactions is you have to learn how to assign oxidation numbers. And we went over this in the beginning of the year about the different families and what they have. And group 1 is always a +1. Group 2 is always going to be a +2. That is not going to change. When you get to the halogens, the fluorine and chlorine and bromine, those are always going to be -1s, and that will not change. Oxygen is always going to be a -2 unless it's a peroxide, which is a polyatomic ion, and then it's going to be a -1, and we talked about that earlier. Another thing is a diatomic element is always going to have an oxidation number of 0. So if you see like H2, you're just going to assign that a 0 oxidation number. Also, any element that is by itself is going to have an oxidation number of, if it's a fluorine or chlorine, whatever, it's going to be what it is on the periodic table. But if it's uncombined, so it's by itself, it's going to be a 0. So if it's like magnesium by itself, 0. Now magnesium with something will be, if it's magnesium and fluorine, magnesium fluoride, fluorine's always a -1, so then magnesium is going to be a +2. And when we did nomenclature, we talked about that and how the total charge of a compound has to be 0. So you have to figure it out on what the oxidation number is. So that's the number one thing that we start off on, and that's where you have the 9 rules on your guided notes. That an uncombined element has an oxidation number of 0. Diatomic element has an oxidation number of 0. Oxygen's always -2. Fluorine's always going to be -1. The group 1 metals +1, group 2 metals +2. Hydrogen can be a +1 or a -1. If it's on the left side, it's a +1. If hydrogen's on the right side, it's going to be a -1 of a compound. So if it's, HX, it's a +1. If it's XH, it's a -1. And then the algebraic sum of any compound has to be 0. So if I have a polyatomic ion, it's like SO4, and the total charge of that polyatomic is a -2. How do I solve that? Well, we know oxygen's a -2, and there's 4 of them. So it's going to be blank plus 4 times -2 equals -2, because the total charge of a polyatomic is going to be that, not 0, right? Because it's whatever its charge is. So it's blank plus -8 equals -2. So what's going to be the charge of sulfur? It's going to be a +6 in that case, because it's got to be 6 plus -8 equals -2. So that's how you solve for the charges of a polyatomic ion. And then if we're just doing normal compounds, like I did over here, the subscript times the superscript is going to give the total charge of that side. Subscript times the superscript is the total charge of that side, and the total charges have to cancel each other out. Okay? So the +2 is going to cancel out the -2, so it's good. All right, now as far as a redox reaction, what does that mean? Well, you're going to see, you're going to have normal reactions, and you're going to have to pick out what lost electrons and what gained electrons. So let me have an example here. If you've got like a, we'll say copper plus magnesium fluoride yields copper fluoride plus magnesium. All right, the first thing you do in every step, the first time, is you assign the oxidation numbers. So you look through it. Any uncombined element is going to have an oxidation number of 0. Okay, if it's combined, you look at the nonmetal. We know fluorine's a -1, and magnesium has to be a +2 in this case. All right, because the total charge has to be 0. And it's 2 times -1 equals -2. 1 times +2 equals +2. Then you come over here, copper with fluorine. We don't know what copper is because it's a transition metal, right? But we know fluorine's a -1, and there's 2 of them. So my total negative charge is -2. 1 times blank is going to give me a +2. So what's that have to be? +2, right? 1 times +2 gives me +2 because it has to cancel out the total charge. And then magnesium is now an uncombined element, so it's a 0. All right, so now what are we looking for? We're looking for what gained electrons and what lost electrons. The hardest part of this whole thing is understanding that when you gain electrons, you get more negative because you're gaining negative charges. When you lose electrons, you get more positive. So what is happening? Let's look at it. Copper is going from 0 to +2. Did it get more negative or more positive? It got more positive, so it lost electrons. So that is oxidation. So my oxidation reaction is going to be copper going from 0, okay, to copper +2. And how many electrons did it lose? If it goes from 0 to +2, it lost 2 of them. So it's copper goes from 0 to copper +2 plus 2 electrons, right? And it's losing electrons. How to remember that? Just think oil. Oxidation is loss, okay? So then what is the reduction reaction? Reduction means it gains electrons. Just think rig. So oil rig. Reduction is gain. So look at magnesium. It went from +2 to 0. And I know that's hard to think, but it got more negative, right? Because it went from positive to 0, so it's going more negative. So that, the half reaction for reduction is going to be magnesium +2 plus 2 electrons makes magnesium 0. So for the reduction reaction, this is called a half reaction because it's half of it. This is half, this is half. For the reduction reaction, the electrons are in the reactants because they're gaining. And they're making that, okay, which is more negative. For the oxidation reaction, the electrons are in the products because it's giving them off. It's losing them. All right, so a couple of key terms, all right, is oxidation is loss of electrons. So if you're losing electrons, what are you going to do? You're going to be getting more positive. So that's what you're looking for, okay? It's getting more positive. Reduction is gain of electrons, so you're going to be getting more negative. That's important to understand that. Now, they are the same, like +2 and minus, or +2 and -2, like they're gaining 2 and losing 2, so that's already balanced, so that's a good thing. And the reaction's already balanced, so that's easy. It's going to get a little harder when we have to balance the reaction because you might have to like multiply the whole thing by a coefficient. So if you're losing 4 electrons, okay, then you'd have to multiply everything by 4, and that helps you balance the reaction anyway later. We'll get to that at a different point. Now, the last 3 terms is a spectator ion, and a spectator ion is an element whose charge stays the same. So which one of these elements did not change? Which one of the charge stayed the same?
Fluorine.
Fluorine. So fluorine, in this case, is our spectator ion equals fluorine because it stayed -1 here and it was -1 there. All right, so fluorine is our spectator ion. All right, now the reducing agent and the oxidizing agent. All right, now these are 2 terms that they kind of blow your mind a little bit, but just think of James Bond. All right, reducing agent is the element that gets oxidized. That means it lost electrons. Well, you're like, wait a minute. Reducing, I thought reduction was gain. Remember, it's a double agent. What happens in James Bond movies, right? The girl's always really nice to James Bond, but really she's working for the other side, right? Well, think about it this way. The reducing agent gets oxidized, so it's working for the other side. The oxidizing agent gets reduced, okay? So the agent is going to do the opposite of what you think it is, right? So oxidizing agent gets reduced. Reducing agent gets oxidized. So which one of these is the reducing agent? Which one got oxidized? The oxidized was copper, right? So the copper is the reducing agent because it got oxidized. The oxidizing agent is magnesium because it got reduced. All right? So I know it's kind of a, opposites thing, but just think of it that way. It's a double agent. That's why it's the opposite thing. So we really need to understand the key terms. What is oxidation? It's a loss of electrons. Its half reaction is going to have the electrons in the products. Reduction is a gain of electrons. Its half reaction is going to have the electrons in the reactants. And then you've got spectator ions, reducing agent, and oxidizing agent that you have to label for each problem. All right? Good job.